All right, let's dive right into this explainer. Whether you're just tapping your phone screen, yelling at a smart speaker across the room, or looking toward this wild future where devices literally read our neural signals, the way we communicate with tech is evolving at warp speed. So today, we're unpacking the invisible rules governing the whole shebang, the actual science of talking to machines.
We have all been there, right? The sheer frustration of repeating a dead simple command to a smart speaker only to have it completely misunderstand you. Or, stubbornly turn off the kitchen lights instead of the bedroom. But why exactly does that happen? I mean, in an age with such crazy advanced AI, why does simply speaking to a machine still feel like an uphill battle? Well, to get to the root of this, we first need to look at a German academic concept called Mensch-Machine interaction. Basically, human-machine interaction. It's this massive, interdisciplinary field of research. It pulls together computer science, psychology, design, cognitive research, the works. And it does all this with one unified goal: figuring out how to make our tech truly accessible, simple, and actually useful. So here's exactly how we're going to unpack this whole mystery today. First, the human-machine connection. Second, the voice interface problem. Third, synthesizing a solution. Fourth, the 14 voice guidelines. And finally, the future of interaction.
Section 1. The human-machine connection.
So, according to the ISO 9241 standards from our sources, which, by the way, acts as kind of the international rule book for digital ergonomics, any interactive tech has to achieve a few foundational goals. Whether we're talking about a physical workstation or a piece of software, it absolutely must prioritize simplicity, accessibility, and usefulness. If a system misses these three pillars, well, it just flat out fails the baseline test of human-machine interaction.
Section 2. The voice interface problem. Now, the absolute crucial point here is how those baseline usability goals actually apply to the voice-first tech we use every single day.
Because there is a massive divide in design right now. Think about graphical user interfaces, the screens on our phones and laptops. They have universally established gold standards. We've literally had decades to figure out exactly where a back button should go, but voice user interfaces, they are still the Wild West. They suffer from highly fragmented, completely unvalidated design principles. Up until recently, there simply hasn't been a universal rulebook for how a machine should talk back to us.
And because of that lack of consensus, commercial voice assistants suffer from some pretty severe usability issues. The research actually shows users have a really hard time recalling spoken information. They struggle with a total lack of clear system feedback, and they constantly run into speech recognition errors. The end result? Extremely high user abandonment rates. People just get annoyed, and frankly, they stop using the tech altogether.
Section 3. Synthesizing a solution. Now, what's really fascinating here is the massive academic undertaking that was launched to solve this exact crisis and finally bring some order to voice design. Researchers at the University of Toronto set out to fix this fragmented landscape using a rigorous methodology known as the PRISMA process. They basically started with over 5,000 disparate studies from major scientific databases, and then carefully filtered them down through this massive funnel until they were left with a core set of 40 highly relevant, peer-reviewed papers. And from those 40 papers, they meticulously extracted a staggering 336 completely separate voice design guidelines. I mean, think about that for a second. If you're a developer trying to build a smart speaker app, trying to juggle 336 different, sometimes totally conflicting rules, that is practically impossible. To make matters worse, those 336 guidelines were scattered all over the place. They spanned 28 different academic disciplines and conferences. We're talking everything from human-computer interaction to signal processing, even automotive user interfaces. Everyone was just trying to solve the problem in their own isolated silos. It really proves just how desperately a unified standard was needed. So the researchers rolled up their sleeves and went to work. Through some really deep thematic analysis, they elegantly synthesized all 336 of those chaotic rules down into just 14 unified gold standard guidelines. They grouped overlapping ideas together, merged similar codes, and essentially distilled decades of fragmented research into a single, highly actionable framework. Section 4. The 14 voice guidelines. Okay, let's dive into exactly what these finalized rules entail and how they're actually going to change the way machines speak to us. This new gold standard covers a really vast spectrum of design requirements.
It ranges from ensuring the conversation actually matches the specific task at hand, all the way to creating engaging, positive personas and, crucially, protecting user privacy. It's basically the ultimate map for developers to finally get voice right.
When we zoom in on the absolute must-haves from that list, 4 major pillars really stand out. First, systems have to mimic real-world conversational norms. They need to feel natural to us. Second, they have to drastically reduce the user's short-term memory load by breaking tasks into smaller chunks. You shouldn't have to memorize a whole voice menu. Third, they must provide incredibly transparent feedback. And fourth, they have to give the user massive control to just interrupt or correct the system at any given moment. But there's a really fascinating caveat here. While the system should feel natural, the researchers found we have to balance realism with efficiency. As one designer noted in the study, human speech is, well, often pretty indirect, rambling, and highly inefficient. So we shouldn't actually program machines to copy those specific flaws. We essentially want the easy flow of a human, but the sharp precision of a machine.
Despite this incredible synthesis, though, the researchers uncovered some truly alarming gaps that are still plaguing the industry. Get this. Out of the original 336 guidelines, only 7 focused on accessibility for users with impairments, like the DAF for hard of hearing, and only 25 focused on data privacy and security. As we move forward, these are massive blind spots that the tech industry desperately needs to fix to make voice text safe and usable for absolutely everyone.
Section 5. The future of interaction. Let's move toward the absolute next frontier of all this.
Our sources indicate that just as we finally begin to master voice, the boundaries of interaction are already expanding again. The German research on mensch-machine interaction points out that the absolute next frontiers are augmented reality, social computing, and most astonishingly, brain-computer interfaces. I mean, we are literally moving from tapping screens to speaking into the air to directly linking our minds to machines.
And this transition is definitely not just science fiction. It is well underway. This is being heavily explored in cutting-edge research right now, like this spotlighted paper from Vanderbilt University looking at non-invasive ways to link our neural activity directly to computers. We're actively figuring out how to translate brainwaves into digital commands, all without needing any kind of surgery.
Which leaves us with a pretty provocative final thought to wrap up this explainer. If it took this much academic effort, literally reviewing thousands of papers just to synthesize 14 complex guidelines, all to standardize speaking out loud to a smart speaker, what on earth is it going to take to safely and effectively design an interface for the human brain? It's a thrilling and honestly slightly terrifying frontier. Thanks so much for joining me on this explainer, and keep questioning how you interact with the world around you.